Hey everyone, Tom from Ignite Digi here. On this video, I'm going to talk through the Ronin 2 gimbal setup with our control deck for DJI Transmission. There are two ways to rig the Ronin 2 for use with the control deck. The first is a simpler way, and that just involves gimbal control and video transmission. And that would be where you have a first AC running a totally separate fizz system, ARRI, Preston, etc. The second is a more complex way, which involves the DJI LiDAR hub, the LiDAR, and a Focus Pro motor. We'll talk about that next. I'll start with the simple setup. So come around here. You can see here I've got the accessory mounts. So we sell these in a pair, Ronin 2 accessory mounts, and these are a great way to mount transmitters, counterweights, etc. The idea is it lives on the gimbal, so when you slide your camera off, you've got your counterweights on the gimbal rather than on the camera. Video transmitter here, first thing you might notice is the low profile antennas. So we sell these as a pair. They're a great way, particularly for the Ronin 2, just gives you that little bit more room, which means you can run the arm at a shorter length, which means your overall build is smaller and you're able to run to higher motor settings. The next thing is obviously the SDI, got from the Komodo body to the input here. Up here I've got the 6-pin, so that's running 6-pin straight down here on the power hub, and then getting you 6-pin female up here. So 6-pin straight male to 6-pin riding a female. And that's powering the transmitter, but also taking data from the transmitter back to the gimbal so that we can have gimbal control. It'll also do run stop. So if you have a cable plugged into the 14-pin here, the RSS port, which we've got the 9-pin EXT version here for the DSMC3 cameras, KOMODO, KOMODO-X and Raptor. That gives you run stop. With the ARRI cameras, we have a 14-pin to 3-pin Fischer that also works on the Venice, and it also works on any of the breakouts for the Burano or the DSMC3 cameras. Lastly, I've got the cable around here, so that's powering the camera. So that's 6-pin straight to 2-pin LEMO female for the Komodo. We also have plenty of camera power cables for the Ronin 2, so if you're looking for any of those for the Venice, Burano, etc., we have all of those in stock as well. The most important thing about this setup is that you are running the cable from the transmitter into the power hub. On the old Pro wireless receiver, you used to have to run it down here on the pan 6-pin. It's the opposite is true for the DJI Transmission video transmitter. So you have to have that into here. You can plug it up in here and you will get power, but the data will not flow through from there down into the actual control of the gimbal. DJI quirk. So this straight 6-pin to right angle 6-pin is our cable, and that's Ronin 2 to DJI Transmission cable. DJI include this with the video transmitter High-Bright combo pack, and this is a straight to straight. So you can see here, it's quite a stiff cable, it's quite a long cable, and imagine that plugged in, and then you try to run that around. You end up running these arms longer just to accommodate this cable on here. Obviously, if you mount it somewhere else, this cable can be useful, but if you want to use the accessory mount, then we recommend our right angle to straight cable, just to make it nice, neat rig. If you're in a pinch and forget a cable, then the right angle male to right angle female 6-pin cables we make for the control deck and include with the kits, they do work for this transmitter from the Ronin 2. They're a little bit short, but in this setup they would work. So first thing to set up on the Ronin 2 screen is to go into remote and make sure that in pan, tilt and roll motion, pan, tilt and roll, you've got deadband set to 0. This will ensure that when you're using deadband here on the control deck, that you don't have double deadband. So you don't have deadband on the joystick and then deadband on the actual input to the gimbal. So you want to make sure your deadband's on 0 on the gimbal itself. And that will also change depending on the user profile, which I'll talk to you a bit later in the video. You want to make sure that across the different user profiles you've got, that you've always got deadband as 0. Now that we've got the transmitter rigged and plugged in and powered, let's go to the control deck and talk through the different functions available in this setup. Obviously on the joystick, we've got pan, we've got tilt, and we've got roll. On the top button here, I've got roll recenter is a short press, and a long press is tilt direction. So that changes from up is up to up is down, depending on your preference. Going left to right now, we've got master rate. So that dials all of the axis speeds down together. So once you set your ratio of pan to tilt and you're happy with those maximum speeds, you can just ride that. Iris obviously does nothing in this setup. Focus wheel does nothing in this setup. The rocker does nothing in this setup. Although if you wanted roll to be on the rocker, you can set that in the menu. Next up is run stop. So you can hear that's now running. I can see that on the SDI overlays that I'm running. You don't get the LED here because there's no confirmation back from the Ronin 2. So we're unable to confirm it by putting the LED up there, which you would get on the 4D or the Inspire 3. Pan speed, you've got pan recenter, which is a press there. You've got tilt speed, tilt recenter, and then obviously I'll pan it around. You've got roll trim, so if you want to adjust the roll slightly. Shake works on the Ronin 2 and is affected by smoothness. So if you need to make it very violent, you can turn smoothness down. As you increase smoothness, you'll dampen the setup. So it's a long press to turn shake on and off, and then you can adjust the amount. Deadband is obviously the joystick deadband, so that works. And then smoothness affects both the shake, but also the gimbal smoothness. So it's basically the smoothness at which it'll start and stop the move. So obviously very direct input if you turn smoothness off, and then very smooth start and stop. In terms of buttons, mark, clear mark does nothing. Exp and peak, they work because they're obviously talking to the monitor. So I've got focus peaking, so I've got false color set up in my menu. So the menu, you can set that up is here, custom hand grips, left hand grip, and then you can set waveform, false color, zebra stripes, depending on what you want. So I like false color, and then a long press will jump out of false color and put peaking back on. So that's a good way. Short press for exposure, long press for peaking. Next, AF/MF obviously does nothing. Long press on this goes to the menu. We'll talk about that after this. And then here we've got recenter, so that's all axis recenter, so you can see there. And then mode is long press of this button. So what that's doing is switching between user profile 2 and user profile 1 on the actual gimbal. So you can set up different modes. So whether you want it to be free, obviously, so then you have full control and it has no input. If you're on the car, you can then set up user profile 1 to be locked. So then that way, if you're driving to the next location or turning the car around and you just don't want to have to ride the joystick, you could switch that. So that's basically a shortcut to switch between user profile 1 and 2. The other thing that you can do in user profiles on the gimbal is you can set limits, so pan limits, tilt limits, and roll limits. So if you wanted to do a shot where you started perfectly tilted down and then perfectly tilted to 90 degrees or to level, you could set a user profile to have those tilt limits. So, 90 down and 0 up, and then you could just nail the shot. Bang, 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 all day. Down here in the menu, joystick expo changes the curve of the joystick. That of course works with the Ronin 2. Twist axis, so you can enable or disable this twist axis. Zoom roll swap, so currently that's roll, but you could swap it to the rocker if you wanted. Fizz control on and off, obviously in this case it makes no difference because we have no fizz. Focus range not applicable. Focus knob cal, so if you find that in other setups you needed to be able to calibrate this, it wasn't hitting end stops or that sort of thing, for the i3 and the 4D, that's where you could calibrate that. Roll speed, so it's got slow, medium, fast. We are going to add a off or a 0 mode as well, so that if you wanted roll to not be enabled, you could do that as well. Shake mode, so that's adjusting the different shake modes, like the algorithm and how it shakes. Shake on move means any axis that's getting a remote input, is it also shaking on that axis or is it not? Because sometimes you want to have the smoothness and it's shaking on tilt, and as you're panning, it's not shaking while you're trying to pan. So you can enable or disable that. Shake on pan, on or off. Shake on tilt, on or off. Shake on roll, on or off. RS motor, not applicable in this setup. And lastly, R2 user profile. So this is where you can set up 1 to 5. So through the gimbal back screen here, I've just got push pan on. You go around, you go to setting, and you go profile. And then you can change between the user profiles here. To set them up, you go into remote, and then you can set different limits here. And then you can also set the modes. So if you change here to be free, or car, or drone, the other setting you can change is axis mode, 2 or 3 axis. So if you're using this with a heavy lift drone and you're landing on fixed landing gear on the gimbal, you could set up user profile 1 or 2 to have 2 axis, and the other profile to have 3 axis. So when you are landing and taking off, you're in 2 axis, so the pan motor's not spinning the drone around, and then you take off, press that, switch into 3 axis mode, do your shots, back into 2 axis, land. So that's it for this simpler setup. Next, we'll go through the LiDAR, focus motor, and LiDAR hub setup. So first thing to set up on the Ronin 2 screen is to go into remote and make sure that in pan, tilt, and roll motion, pan, tilt, and roll, you've got deadband set to 0. This will ensure that when you're using deadband here on the control deck, that you don't have double deadband. So you don't have deadband on the joystick and then deadband on the actual input to the gimbal. So you want to make sure your deadband's on 0 on the gimbal itself. And that will also change depending on the user profile, which I'll talk to you a bit later in the video. You want to make sure that across the different user profiles you've got, that you've always got deadband as 0. DJI make 2 versions of the LiDAR hub. If you want to go on a deep dive about the differences, the pros and cons of each, you can check out our video. I'll cover the rigging on this video, and I'll also cover the specific cable you'll need for each LiDAR hub. So first up is the RS LiDAR hub, and this has a USB-C at this end and a 6-pin male at this end. So this plugs into the power hub, and then this plugs in to the socket here on the RS LiDAR hub. And basically that's only doing control data from the transmission back to the Ronin 2. The power source is obviously the DTAP here to power the transmitter, the LiDAR, and the motor. If you have the newer Focus Pro LiDAR hub, which I would recommend if you don't have either of them yet, it's a bit neater, which you'll see in the video. This is the Focus Pro LiDAR hub cable, and this is a 6-pin male. So again, goes into the power hub and goes to a 7-pin male 0B LEMO. So this not only does data back from the transmission into the Ronin, it also does 14.4 volts from the power hub on the Ronin 2 to the LiDAR hub, and then out to the transmitter and the motor and the LiDAR. So this is the one we're going to use here on this rig. So I'll just spin it around, and you can see where I'm hiding the LiDAR hub here. I've got it here on the side of the transmitter, which is mounted to the Ronin 2 accessory mounts that we make. Now the reason I've got it here on the op side is for balance. So when I had it on the other side, it was pushed too far across, and then this motor here couldn't go across any further because of the USB sticking out. So what I did is move the transmitter over to this side, and then that pushed the camera balance across and gave me room to slide the camera back and get that motor in there. So again, you'll go through trial and error and work out, depending on your rig, which side's better. With the LiDAR hub, we've made the cable long enough so that you can run the transmitter on either side. So you've got options. So I'll just quickly plug this in. I'm going to come through the front here, and I put the LiDAR hub on this side so that this LEMO would stick out forwards rather than out to the back. So then that routes around, and again over here into the power hub. In this setup, I've got the transmitter on the accessory mount. For this rig with the Komodo and the KEYSTONE here, we prefer to use our carbon side plates. So through Movie Magic, we'll quickly snap my fingers and we'll change over to the carbon side plate, and I'll talk about some of the benefits there. So here it is on the carbon side plate, which goes on the KEYSTONE for Komodo, KOMODO-X, V-RAPTOR and the FreeFly Ember slow-mo camera. So being here on the side plate is obviously a very neat solution for the gimbal, and in this case it's a great counterweight for the small body Komodo. Not only is it a neat position for gimbal, when you go to tripod, handheld, Steadicam, any of the other modes, obviously the TX is already on there. So once you unplug a couple of things, you slide the camera out, slide the top handle in, drop it onto a bridge plate, or slide into a Steadicam or a tripod, you're ready to go. We also have a carbon side plate for the Arri Alexa Mini LF, so using those side M4 hole spacing. So if you need to get your transmitter mounted nicely for those, we recommend that. All right, now we're going to go into the cabling. There's quite a lot of cables going on in this, so I'm going to start with the simple ones, which is, down here on the DC out. We're going DC out to 2-pin female LEMO, which is the Komodo input. So that's 14.4 volts into the camera. Coming around here, I've got the RSS 14-pin running up to 9-pin EXT. We also have a 3-pin Fischer version of this cable. So if you're running a EXT breakout with the red cameras, or you're running a Venice or a Arri Alexa camera, you can use those cables. Next, I'm going to go the cable I mentioned before, which is the 6-pin male, so R2 power hub, up to the LiDAR hub DC in up here. So that obviously that's DC in, but it's also CAN bus out, so data's going back to the gimbal from there. Right, next let's go the transmission TX output. So that's included built into the LiDAR hub, and that's a USB-C into the transmitter and a 6-pin female that plugs into the transmitter there, and that's supplying power and also data, bi-directional data, which gets back to your screen but also feeds to your gimbal. On the top here we've got the LiDAR, so that's feeding out around under the rods and here to the dual USB-C. So that dual USB-C has an orientation, just have a look at those little symbols to match the underneath symbols. All right, back to the LiDAR hub. Got the focus motor down the bottom here, coming around, it's going through the rods and coming around to this side over here. So I've got a Focus Pro motor here, and this is set to focus, F, and you can see here the high voltage warning. So that's how you know you've got the right cable. On the other side here, I have 2 more Focus Pro motors. This one is on the iris and this one is on the zoom, and they are on iris and zoom mode. I've calibrated those and they are cable wise. I've got the DTAP breakout, I've got the DTAP to USB-C into the first motor here, and that's feeding 14.4 volt into this motor. Then this cable runs out and around and into this motor, and that's feeding 14.4 to that motor. It's also data sharing. So one of these, I think it's the iris motor, is linked to the Focus Pro hand unit, and then the data also passes through to the zoom motor. So you may think, like, why have you got 2 motors together and then this third motor is separate? Well, as of October, which we're shooting this video in, October 2024, there are some limitations around motor control via transmission. So obviously I have 3 motors here, but I'm only going to be controlling this motor via transmission. These 2 motors are going to be controlled by their internal 2.4 gigahertz link. So this is the Focus Pro hand unit, and this has an internal 2.4 gigahertz link to these motors. So in this setup, I've got iris and I've got zoom, and this 2.4 gigahertz link is good for 100 to 150 meters depending on your region. Whereas this motor over here on the Focus, I've got control here on the control deck, and I have that for whatever the range you get out of your video transmission system is, which, you know, in theory is 3-4 kilometers for most people with DJI Transmission. So you got a mismatch. So you'll be in situations, you could, with this rig, you could be in situations where you as the camera operator have control of the gimbal, you have video, you have one motor control, but your first AC who's using this has lost their link. So we are pushing DJI to allow 3 motor control via transmission, and we think it's a really important thing for their pro ecosystem. So in that setup, you know, in the ideal setup with some firmware updates from DJI, you would then just be able to run looped out of this motor into this motor, loop out of this motor to this motor, and then set them to focus, iris and zoom, and then have focus, iris and zoom on the control deck, or join this via the high bright bracket or our control link, and that goes into the high bright monitor, and then you've got 3-channel fizz via transmission. So currently the limitation is 1-channel fizz via transmission. And obviously if you use the LiDAR and you want the LiDAR overlays, which you can see here, I'm going to turn them on. So I've got this lens is already calibrated in C3 position. So you can see here I've got the LiDAR overlay, I've got the heat map, the focus heat map, which is pretty cool. It is going to get a little bit more confusing in the next section where I talk about how these motors are controlled via absolute. So, you know, 0 to 999, say, just out of interest sake. Positional, you know, end stop to end stop. Whereas this is controlled via transmission, rate based. So rate based means a direction at a speed. So there is no hard stops as such. Obviously our control deck, we have hard stops on the wheel, and those hard stops work perfectly on the Inspire 3 and the 4D, which are via transmission. So you can do absolute via transmission for the Inspire 3 and the 4D, but for the Ronin 2, this wheel and the way that it's controlling through transmission is more like the 4D grip on the side. So it's the wheel that just keeps spinning. So this focus wheel, you obviously have marks. You have marks on the lens knows where, you know, infinity is and everything like that. But the actual ratio of this won't match every time. So if you move it fast or if you move it slow, that'll change. You won't always have a perfect mark to hit. So that's the limitation with that. On here, if you linked it for your first AC and everything was done on here via the 2.4 gigahertz link, that would be all absolute. So it sort of caught at this awkward position where DJI have this great ecosystem and of Focus Pro and this great ecosystem of DJI Transmission, but it doesn't fully work together in the way that professionals would like it to. So we'll continue to encourage DJI and you know, if you want to sign on to a petition, we've got a petition on the Facebook page, which we'll link to in the description, and you can put your comment there and say, hey, like, I think this is really valuable, DJI. We'd love to be able to control 3 motors via transmission. Because we're controlling this focus motor via transmission, it's a rate-based system. So move this direction at this speed. So to adjust the range of this motor, we need to go into the high bright settings. So go here, general settings, custom hand grips, right grip, and then the first setting you can do is you can invert the direction, and then the second one is focus speed. So for this Angino, I've got it on 3, which I find gives me the full range of the lens here. Obviously it's not exact. If I move it faster or slower, it won't always hit the exact endpoints because it's a rate-based system. But I find that 3 gives me the ability to hit infinity and minimum focus on the Angino. So if you were using a stills lens with a much smaller range, you would probably go to 1 on here. And again, yep, that's where you invert the direction. So the next rig I'm going to show you is where you have a first AC, you want them to have all 3 channels of fizz control, and you want them to have the LiDAR overlays. So we'll start on this side of the rig. First thing you'll notice is that I've unplugged the death cable, the DTAP to USB-C, and that's because we're going to be drawing power through the LiDAR hub. So get rid of that cable first, and then over here you'll notice the next thing is up top we've got a USB-C to USB-C. So that's joining the focus motor that was previously separated from these motors, and that's bringing power through and also control both ways. So this doesn't give you 3-channel control through the control deck, unfortunately. What it does give you is you'll have zoom, you'll have iris, and then you'll have focus. But you may have jumpiness. So it's a pretty simple fix. So you can see here on the motors, you've got green solid, and that means that this motor is calibrated and it's also the one that's linked to the hand unit. So that's linked because that's what we had in the previous rig. You can see here, red solid means calibrated, but not the one linked. So that's getting data from this motor to here. And then if you have red flashing, that means it's not the linked motor to this hand unit, and it's also not calibrated. So to fix this jumpy focus motor, just come around and link the focus motor to the hand unit. So to do that, you just hold that button and you hold the M, and you can see it's linked. So green, solid, and now smooth. So in this case, I do have fizz on the control deck, and you can control the motor while also the first AC has control here. The issue is that this is an absolute based system. So the position of this wheel is relative to the position of the motor. So this is what you want for focus. You know, it's an absolute. This position here is that position there every time, so you can do marks. But the control deck, because it's going via transmission, it's rate-based system. So if you move this and then you move this, whoop, see? So we've moved the motor, this doesn't know it's moved, and then obviously you have a problem. So in this case, I would turn off fizz. So go into the menu of the control deck, go down to fizz control and turn it off. And then that way, if you move this, it won't affect the motor. And then if, say, your first AC went to the toilet and you need to take control of the focus again, you just go into the menu and turn fizz control back on. And that way you can share the focus. So this way you also will get the LiDAR overlays on the high bright monitor for your first AC. But now with the latest firmware of these motors and this hand unit, you also get the LiDAR readout here, which is cool. Right. So this distance readout is actually the LiDAR's distance to the subject. So if you've got a person in shot, then it's going to be their face. It's not the distance that you're currently focused. And to turn on AMF, you just press the M button. And you can also set sort of endpoints with the AB on this. This next setup, the operator has zoom control, and the first AC has iris and focus with LiDAR. First thing you'll notice, the motor here on the zoom position of the lens is now in F mode or focus mode. So it used to be in Z and now I've changed it to F. It also is getting the motor cable from the LiDAR hub. Secondary, down the back here on the iris motor, you can see I've got the death cable, the DTAP to USB-C going into it. And I've got it in iris mode and it's not the linked motor. Then this USB-C here is crossing across the rig. I'll just pan it around over to here. So we're feeding that into the focus motor and you can see the green, so that's linked with the hand unit. I've then got a USB-C coming out of here, I'll spin back around, going into the LiDAR. So that front LiDAR port, it's important that it's the front LiDAR port. So we'll come back around. So you can see, yeah, I've got the green, I've got the link, I've got focus, I've got iris, and then coming over to the control deck, I've got zoom. So even though this motor here is on F mode, it's on the zoom position, this is the mode. So if you put that on iris or zoom, this transmission link won't see the motor, won't control it. So obviously you could use the focus knob on the control deck to do zoom, but it'd be nicer to use the rocker. So we'll put a menu setting and I'll show you how to get to that. So you go setup. Obviously you need to make sure that fizz control's on, then go down to RS motor and change that to rocker. So now you'll see we've got the zoom here. So if you want to invert the direction. So you want that to be zoom in, zoom out. Then I'll show you how to do that in the menu settings. So go menu, general settings, custom hand grips, right grip, invert, and then now you've got in and out to the logical direction. I would also put the speed down to one because put the speed down to 1 because zoom lenses generally there's a lot less travel on the zoom. So now you can see I can do a nice slow creep, or I can zoom in reasonably fast. Obviously you can see I've got no LiDAR overlays here, and that's because the LiDAR is connected to the focus motor and the iris motor and is controlled on here. So we're going 2.4 link to these, and then the only motor that's connected to the transmission is what we're using as a zoom motor, but it's in focus mode. So you will get the LiDAR distance here on the hand unit if you're on the latest firmware for the DJI hand unit, Focus Pro hand unit, but you won't get the LiDAR overlays and heat map on the high bright monitor. In all of these setups, the record button on the hand unit will not work. So your operator using the control deck will have run stop here. You will not get a red LED confirmation on the control deck, and that's because the Ronin 2 doesn't send back a confirmation via transmission. So you'll have to rely on the SDI overlays. I've got the Komodo here. If you had a micro SD in the side for the proxies on this monitor, this will also trigger those. But yes, your first AC will not have run stop. The operator will have run stop on the control deck. So that wraps up 3 ways to use the control deck with the Ronin 2 with 3-channel fizz. Obviously it's not quite what we hoped initially, and we are working on some workarounds with some nucleus motors, hopefully available soon. When you come off the gimbal, it's likely you still want to use the LiDAR hub and the 3 motors, but you don't want to use the control deck to control the focus motor. You probably want your first AC to have full control on this setup. So we do have a couple of cables for use with the LiDAR hub off gimbal. The first one of these is a DTAP to 7-pin. So that's feeding 11 to 17 volts from a DTAP battery source into the LiDAR hub. So that'll power the transmitter, the LiDAR, and the focus motor. Next up is a 2-pin to 7-pin. So 2-pin LEMO as the power source, and that's 8 to 17 volts, and then the 7-pin into the Focus Pro LiDAR hub. Next up, I'll talk through all of the functions you have available in this configuration. First, I'll start with the joystick, then move left to right across the deck, talk through some of the menu on the control deck, and then move to the menus on the high bright for some of the settings you'll be using. Of course, pan, tilt, and then roll we've got set to twist. The button on top here, got roll recenter, and then long hold is tilt invert. Long hold is tilt invert. So for those who like up is up, or if you prefer inverted, up is down. Next, I'll move across to the left-hand side. So on this setup, I've got the rocker here. I'm not using that in this setup, but you would be using it if you had the single motor that we're going to controlling via transmission. You can set that to be on the zoom part of the lens. You'd still need to leave the motor in focus setting to do that, and I'll show you how to map it to the rocker when we get to the menu stage. Next is the master rate. So that obviously adjusts the overall speed of all axes and allows you to, on the fly, start with a fast and then adjust down. So you don't have to, you can sort of ride that in shot. Iris is not doing anything in this setup. Focus knob, obviously I've got it on the focus. I've got the LiDAR overlay so I can see. Next up is run stop. So you can hear that's now running. I can see on the SDI overlays that I'm running. You don't get the LED here because there's no confirmation back from the Ronin 2, so we're unable to confirm it by putting the LED up there, which you would get on the 4D or the Inspire 3. Pan speed, pan recenter in the press. Pull that back around. Tilt speed, tilt recenter. There's Gerard behind on the iPhone. Roll trim. So again, you know, if you need to adjust the horizon on the fly. down here, I've got the buttons. Mark, clear mark does nothing on this setup. That's for 4D and i3 only currently. EXP and peaking. So EXP, I've got set to false color. So that can toggle that on and off. Annoyingly, if you go to false color and back, it doesn't enable peaking again. So my trick around that is short press for EXP and then long press turns off EXP and turns on focus peaking. If you want to change to a different setting, you can go up here, general, custom hand grips, left hand grip, EXP button. Waveform, false color, zebra. So if you go waveform, then let's press EXP, waveform comes up. And again, long press to get out of it and to turn peaking back on. All right, next button, AF, MF. That is going to do something in this setup because we've got the LiDAR. I've calibrated this lens, which you can do here in the settings. So turn that on and now the lens is doing autofocus. And then I don't have any control here. So this wheel, the only thing this wheel will do when you have, so obviously it likes faces, so it's like Strad there. And if I move this, I would be able to jump. If I had two subjects, I'd be able to jump between subjects. When you've got autofocus enabled, this focus wheel will do nothing. So you need to turn autofocus back to manual focus and then you'll have control again. All right. What are we up to next? Setup, so long press on that button will get into the menu. I'll go through that in a second. Recenter, so short press for recenter, that's all axes recenter. So obviously, you know, be careful being this close. And then last is mode, so that's long press here. And that jumps between user 1 and user 2 for the Ronin 2. So you can quickly jump between, say, 3-axis and pan lock mode for heavy lift if you're landing on fixed landing gear on the Ronin 2, or if you want you're doing car tracking and you want free mode to be user profile 2 and then locked mode, so you can just press that long press on there and then take your hands off the control and you know that the gimbal's not going to end up panned back into the car when they're doing a U-turn or whatever. So that's a nice little shortcut. Now let's jump into the menu. Long hold jumps into the menu. And again, at any point in this menu, if you long hold that, you'll jump out, and then long hold back in, it remembers where you were in the menu until you power cycle the control deck, in which case it then will then put you at the top of the menu. So that's a really nice feature. And while the menu's up, you can adjust any of the pan, all of those sort of, anything except the buttons kind of works when you're in the menu. So you will never miss a shot. You can hit run stop and the camera's going to roll. So menu, let's go back up to the top. Exit menu, obviously that's the kind of slow way to exit the menu. Go up there and press left or right. Joystick expo, we've got linear, squared and cubic. We'll show the chart here and you can see the differences. I really like linear and squared, but I know some of the users are enjoying having cubic. Twist axis, on or off, so that's on the joystick itself, enabling or disabling the twist axes. Zoom, roll swap, so if you want roll to be on the rocker and zoom, if you had it to be on twist, you can just use that function. Fizz control, on or off. So in this configuration with the Ronin 2, if you're running the single focus motor and you want to have control, you obviously want that on. If you turn it off, it doesn't, there's no real reason to turn it off in this setup. Next up is focus range. This has no bearing on the Ronin 2 rig, so we'll just skip through. That's for Inspire 3 and 4D only. Focus knob cal, so that's calibrating this knob. I've already done it. You would only need to redo this if you dropped the controller or you felt like with the 4D and the i3 that the end stops weren't making sense. But for Ronin 2, obviously the end stops aren't going to be perfect anyway because of the rate-based control. And that's a DJI limitation. Roll speed, slow, medium, fast. Probably on the next firmware we'll add a like a 0 or an off. so that you can, depending how you map things, you can have it so that no roll can be put in other than roll trim. Shake mode, 1, 2, 3, different versions or different algorithms for the way the shake looks. Shake on move. So shake on move was the idea was sometimes when you're panning and you have shake enabled, you don't actually want it to kind of shake as you're panning. You want it to be a smooth pan, but tilt and roll are still shaking. And then as you ease off on the pan to a end frame, or, you know, obviously you generally shake you're using like a tracking vehicle or something. As you ease off, it then eases the shake on the pan back in. So if you have it on, shake on move means it's going to shake, doesn't matter what the joystick's doing. Shake on move in off position will mean that any axis that's getting an input from the joystick, or like the rocker if you had roll on it, will disable shake on that axis while that input is being done. So, you know, give it a try, see what you like, see what you don't like. It'll probably differ based on the project. Next, shake pan on or off. So that's where you can enable shake to affect or not affect pan all the time. Same with shake tilt, same with shake roll. This one, RS motor, so knob or rocker. So currently we have it on knob, which is why we have manual focus here. If I change that to rocker, I would then have manual focus on the rocker. And obviously the reason we didn't necessarily think about focus being on the rocker, it was really about zoom. So if you had this set up, you unplug the LiDAR, you forgot about the LiDAR, you just don't want the LiDAR, you just want the operator who's using the control deck to have a zoom, then put that motor on the other side that's in focus mode, so F, you put that on the zoom position of the lens, and then you'll have a zoom. You'll have a zoom. And I'll show you how to adjust the speed of the motor next. User profile. So not only in mode button do you quickly jump between 1 and 2, you can also go into the menu and go 3, 4, 5 as well. So 5 independent user profiles for the Ronin 2, which is really nice. All right, that's it. So I will RS motor. Let's jump up to the high bright and talk about that. I've put the RS motor to rocker in this case. And if I wanted to adjust the range or the speed of the motor, general settings, custom hand grips, right hand grip, and then here you can adjust the direction, so you can invert the dial direction, because basically the rocker or the knob are imitating the 4D grip. So you can invert the direction of the motor and you can adjust the speed. So the speed is obviously the actual speed of the motor, but it also, because of the rate-based system, it affects the range. So on a cine lens like this, to do focus, I needed it to be on 3. But if I was on a stills lens with a much smaller range, I might only want it to be on 1. 3 will rip through the actual small range too quickly. So that's how you adjust that. And then the other things you'll need in here, obviously the calibrations for the different lenses. So you can do 3 lens calibrations in this. You can adjust the distance of the LiDAR from the sensor. And then you can turn on and off things like picture-in-picture, which is this feed from the visual camera on the LiDAR. You can also zoom it in. So I've got the Focus Pro LiDAR, so that's now in like telephoto mode. So if you had an 85mm on and you wanted it to focus on half as much and have further distance, that the LiDAR will work. All right, jump back into here. Tracking sensitivity, so if you had it on AF, you could, depending on how sensitive, I find 1 is enough. 5 is too twitchy, it'll just jump around too much. The wide and flex spot is a nice idea, but the problem is currently you can't use this monitor to actually pick the spot. So I would just go wide in that case. I'm hoping in the next firmware that DJI allows you to kind of pick the section here in this with the touch. I mean, it's a touch screen, it should work. Lastly, if you are an operator and you don't want any of this focus meter or anything, then you can turn that off here. So you can keep each of the bits independent. So you can turn on just the focus meter and just have that down the side. You can turn that off and just have the waveform. And then you can obviously just have the feed there. and then you can turn that off. So if you like a clean display, so you might have this on your control monitor, and then the other control monitor that's linked, your first AC might have, in which case they'll want all of those things turned on. So I hope that gives you a good idea of where we're at in terms of control deck with the Ronin 2. You know, there's a lot of functionality in there, and it's we think it's a really nice control interface for the Ronin 2. You know, it's a big step up from DJI's controller, you know, which you didn't have any control of smoothness or anything like that on the actual, I've stolen knobs off there. Someone's stolen knobs off there. You didn't have any control here for smoothness. You had to do that on the actual gimbal. So having the smoothness, having the ability to set the curve of the joystick in the menu here, which you can't do on here or you can't do on the gimbal itself. So yeah, if you've got any questions, just reach out on Instagram or send me an email, tom@ignitedigi.com. I hope you enjoyed this deep dive and look forward to seeing you on the next video.